So in the previous few posts, we first talked about recommendation systems in general, and then gave a introduction to reinforcement learning also. And in the last post, which is post number 2, we got into specifics of one of the types of reinforcement learning which we'll be adopting in building our recommendation systems, and which is K-bandit, the K-bandit problems, and we implemented a couple of solutions for the K-armed bandit. Now in this post, what we will do is we'll try to connect both these things together, because this post is going to set the context for building our self-learning recommendation systems, and then we are trying to connect the recommendation systems concepts with the reinforcement learning concepts. Now coming back to the reinforcement learning, we learned in our first post about the overall context of reinforcement learning. We learned that there is this agent, which in our case is a recommendation engine, which takes actions from certain states, and the states give the context for the agent to give or provide actions. Now actions from a recommendation system perspective could be the products which are recommended, and to the environment, and here the environment is the users form the environment, and the environment gives certain rewards or feedbacks, and that is the basis for again improving or updating the value for the agent, so as to improve the whole recommendation process, and that is all what it is. Now looking back into the recommendation systems, one important aspect here is about the states, because the states set the context in which recommendations have to be done. So what we will do in this post is to understand what could be the states in our context, in our problem statement. So what we'll do further down is we will get into some exploratory data analysis, look at the online retail data sets, and try to derive some states from this. Now one important aspect about states is, because states have to be a little distinct. Each state have to be distinct. There should be some amount of demarcations, or some amount of something which differentiates one state from the other. Otherwise, having different states would be meaningless, because why we need to have differentiation is because these states needs to define a certain behavior through which from which, or certain behavior or certain context from which you need to give recommendations, and the buying behaviors of users needs to be distinct within these different states. So thinking ahead from a retail online retail perspective, different states could be, one obvious candidate which comes into mind is the customer segments, because customer segments define specific buying behaviors of each segment, because probably within a segment all the customers could have similar kind of buying behaviors, but there is some amount of distinctiveness between segments, in one segment versus the other. So that could be one obvious choice of a state, and there could be other obvious choices, like say for example different months of year. Your buying could vary depending on the month in which you are in. This could be the case in different types of products. So that's what we will try to observe. Then there could be other granularity from even within the month. Is there some amount of variability, say within the first 15 days or the next 15 days? The rationale is this: the such buying is based on the money you have to spend, and say you are a working professional, and your salary date is in the beginning of the month, then you are more likely to buy in the initial, say first couple of weeks than in the latter weeks. So that's the rationale of looking at whether there is this distinctiveness in the first 15 days and the next 15 days, etc. Or are there any distinctiveness in in terms of the days of the week. Say for example, your buying is centered around when you have time, that is during your weekends, or are there any specific days in which buying happens. So what we will do in this post is we'll do some exploratory data analysis with the online retail set data set, and then look at different candidates for these states, and then look at whether these there is any specific distinct behaviors in each of these states which we are going to adopt for our online self-learning system. And at the end of this post, we will try to connect everything together and give the big picture of how our self-learning recommendation system will look like, and that will be the basis of our future posts. That is, how we build the prototype using a Jupyter notebooks, how you build an application using Python scripts, and then how you deploy, and all these things would be based on the big picture which we present in this post. So let's open our Jupyter notebook, and then let's get into exploratory data analysis. So these are the packages which we will implement. Let's implement them. Now the dataset which we are going to use is an online retail dataset which will be available in the UCI machine learning library. So you can see the links here. I've given the links here, so you can go and download this dataset. I've already downloaded the dataset, so I've kept it in my folder here. So you can also do the same thing. So let's read this Excel sheet using read_excel, and we give the engine open PyExcel, and this is to read into the pandas. Let's look at the head of the data. So depending on the speed of your machine, it might take a little time. So now we can see that the customer details data set or online retail data set have loaded, and this is the head of the data. So you have this invoice number. These are unique for each customers, and then the stock code. This is the product code for the different products which is being bought, and these are the products, the quantities which is being bought, and invoice date, and other details, your unit price, the customer ID, and the country. Now we wouldn't be using this country much, because so we will not be using this. Other details we would require, and date is one important field which we will explore more, because we have to extract different information from the date. This date field, like we need to extract the month, we need to extract the weekdays, we need to extract so many other information from that. So let's look at the shape of the data set. So it's a pretty large data set. Around 540,000 rows are there, and now let's get into the extracting information from the dates. So we'll be using this the package called the date util parser. That is what we'll be using for extracting information from the dates. So this is the code block of code which will be used for passing the dates. Now here what we are doing is we are creating a new variable called the pass date, which will be using the parse method on the invoice date. So we'll get a new passing, because this will be in a certain passing object which will be here in this under this variable, and and we'll be working on this pass date. So we'll extract the weekdays using x weekdays. We'll extract the days. This percentage A, capital A, is how you strip the day from the date. Likewise the month, the year, month. Year, month is only we're just combining both the year and month, which we earlier extracted, into just one variable, so that you have some certain distinctiveness in this. Now once you do that, the other thing which we are going to try to extract is, earlier we discussed about whether there is this distinct buying behaviors in the first 15 days and the latter 15 days. This is based on some assumptions which we are making. So it could be first 15 days and last 15 days. You could also go into a little more granularity, saying that the first every 10 days, is there a distinct behaviors in the every 10 days, in the first 10 days, the middle 10 days, and the last 10 days of a month. Or you could even go by week wise, first week, second week, third week, fourth week. Is there a difference? So it depends on, only problem is when you get into such granularity, the number of states also increases. So you'll have to look into a balance between how many states do you want and what kind of granularity do you want to get into. And another option is, even we said that we would go for customer segments. Maybe instead of customer segments, if we want personalized behaviors of customers, we could even go for individual customer wise and all these states. Only thing is, the number of states would increase exponentially with all those granularity. So the last three lines of code is to extract that the date or the day, the date in which. So here your numerical dates are extracted, so 1 to 30. So that's what is extracted using this %d, and then we convert it into float, and then we are creating a new variable called month period, wherein so it's going to be a binary kind of date, wherein dates where it is more than 15 it will be 1 and less than 15 it will be 0. So that's how it is. Let's implement this. Let's run this.